Well, good morning. Welcome to everyone today. It's really great to see you out. Thank you for coming. We have a treat for you today. And the first treat is you won't have to listen to me talk for very long at all. I just have a few announcements. Just want to share with you what the day is going to look like really quickly. This is our agenda. We want to take you to the place of your student. We want to show you the experiences that they will have being given quality computer science instruction in your classrooms. So the majority of the day, put your principal hat aside and enjoy being a student. We want to introduce you to 3 of the curricula that we have in our curriculum lineup. And so if you brought more than one person with you, you can rotate through and see all 3. Otherwise, you'll get an opportunity to choose 2 of them. So in this room, we'll be introduced to our K through 5 curricula with our friends from Enrico Tante. And then after that, you'll be introduced to Project GUTS, which is the integrated curriculum for middle school in science. And around the corner is an opportunity to see and experience the new curriculum from Apple, which is called Everyone Can Code, and it also is for middle school. So you'll get those choices. So just a couple of things, housekeeping. Out here to the left is the ladies' room, and around the corner, I believe, is the men's room. Men's room is right here, and the ladies' room is right there, sorry. We'll be serving snacks at the break between the first class and the second class. And so you'll get those opportunities to walk around and see this beautiful facility. I also want to give a shout out to Google for always having our back and being our partners and giving us a wonderful place to come out to. Isn't this a beautiful facility? So I'm going to introduce you to one of our partners from Google in a second, and then you can thank her formally. But I just want to remind you, I never wanted to miss an opportunity to share with you just where we are in this movement. We're right in the center. And we couldn't be there if it weren't for the hard work of all of you. The fact that you've decided that even in the midst of all of our trials and hard times, that you've decided to step out and say, this is the most important thing for our children to do, is that I focus on this too and integrate this in to our other work. And from the bottom of my heart, I just want to thank you for that. And to let you know that we stand behind you. We're thankful for you, and we're here to serve you. And so you're going to get to meet a bunch of our staff today. Many of them are not in here, but I'll make sure that you know who everybody is before you leave today. So one of the things that I want to share with you is that we're going to be increasing our communication to you. We've gotten a little crazy and gotten away from talking out loud a lot, but you will be hearing from us, especially as we move into our PD season. And that was one of the reasons why we wanted to share with you and help you understand what the curriculum looks like and what it is that we're going to be offering to you as choices for your schools. I think the last thing that I want to share with you is that, again, today is for you, and hopefully it'll help you understand who maybe, if you're still figuring out who your teachers are going to be that you're going to choose for the lineup and encourage to go into PD, you'll be able to see some of our best teachers in action and see the types of things that they do, and hopefully that'll help you to figure out who's best suited to step forward and take this opportunity. Okay? So with that, I want to introduce to you our partner from Google today, who has opened the doors for us. Her name is Britton Picciolini. I've murdered that. I'm so sorry. And just a little bit about Britton. She is obsessed with all the things digital, from coding BASIC in 6th grade to her Nest thermostat today. Nothing is ever too weird. Working at Google for almost 15 years, she is in love with technology. In the past at Google, she oversaw $600 million worth of business with large retailers and advertising agencies. and someone is calling me. Today, she is helping K-12 schools use Google tools to transform the classroom. Britton taught photography at both Schmid Elementary and Chavez Elementary through Citizen Schools. Britton is married with 2 adult sons, enjoying her empty nest, someday for me, in the West Loop of Chicago. You are likely to find her in an airport because travel is both work and play for her. I'd like to introduce to you Britton, and she's going to give you some great information that I hope you take back with you. Thank you.
Thank you, Brenda. And unless you are Italian or married an Italian, I don't expect anyone to get Picciolini right. So welcome, everyone. It's so wonderful to have you here. As she said, I work with our K-12 education side of the house now. So I actually am the liaison between Google and CPS, in addition to 43 other large districts in 13 states. So when she says I travel, I mean it. So I am on the road a considerable amount, but CPS is my baby. So I am based here in the Chicago office, and I have been for the entire 15 years I've been at Google. So this is my home, and I have a soft spot for CPS. So you guys are my heart. That being said, I am so excited that you're here. So just the mere fact that you all are here means that you're dedicated to a cause that's near and dear to my heart. While I'm not a programmer, I know lots of folks that are, and I love technology and all of the things that come from that. So just to know that you're all here dedicated to the cause means a lot. As you can imagine, over my 15 years, I have seen a lot change, not only with Google, but just in the environment in general that we all live in. I remind people all the time, smartphones just have been around since 2006. When you think about how smartphones have changed our lives and how they have not been around that long, you really take a step back and think about how our worlds are going to look 10 years from today. So thank you all for being here. I did want to share a few stats because I think that these are really important. Illinois currently has 20,857 open computing jobs, over 4 times the average demand rate in Illinois. Illinois had only 1,768 computer science graduates in 2015. Only 13% were female. The average salary for computing occupation in Illinois is $86,131. Way above the average of the average salary in Illinois, which is $49,970. Only 2,900 high school students in Illinois took the AP Computer Science exam in 2016. Only 21% were female. Only 330 students were Hispanic or Latino, and only 52 students were Black. 93% of parents want their children to learn computer science, but only 40% of schools teach it. So as a Googler and someone who loves technology, when I think about the future of what's going to happen, we need more people to understand this environment. And all of you being here to make sure that that happens is incredibly important to me. I encourage you to take all of these stats back to your individual schools. You can find those on code.org. They are available for every single state, and they're very important to actually recognize the shortage that we're going to have if we don't do something about it. So with that, welcome to Google. So excited to have all of you here. I'm going to be here all day, so if there's any questions specifically you have for me, please let me know. With that, I'm going to let the next presenters come up. Thank you for being here.
So with that, I'm going to introduce myself, as Carmen always reminds me that I don't do. So in case anyone doesn't know me, I'm Brenda Wilkerson. I am the director of the Department of Computer Science. And it is, one stat, I don't know if you knew, did you know we didn't have a Department of Computer Science before a couple months ago? So that's already a point of growth for our district. And so and it exists because all of you are here. So once again, I just want to thank you for that. I want to take this opportunity to say that the rest of your day is to be immersed as a student. And so what we're going to do now is ask you to either stay here and experience the K through 5 curriculum, or to go around the corner and we'll have people to direct you if you'd like to experience the Apple curriculum. One note on the Apple curriculum, they just launched the K-12 solution. They have dedicated 200 seats to our teachers in June to come out and get trained in the curriculum. We'll be communicating more information about all of our curriculum, including that one, throughout the month of May, so you can make decisions as to whether or not you'd like to run that curriculum in the fall, but you're gonna get a chance to experience it twice today. So this morning first we're going to experience the K through 5 curriculum in here. After the break, the Project Guts curriculum, but twice around the corner, 20 people can experience at a time the Apple curriculum. So with that, please stand up and follow Carmen if you're going to go for the Apple curriculum. If you're going to stay here for the K through 5 curriculum, I ask you to move into the center so you can become our students. Thank you. Okay.
Set up whatever we need to set up.
Yep.
I'm going to put my drink over here, just FYI.
Okay. Yeah, I'll put mine back here too. Start a timer as well. I guess they're not giving us.
Morning. We'll just wait a few minutes for everybody to settle in or out.
So while we're getting started, just if you want to follow along, this is going to be an interactive presentation. So please, if you have a phone or a tablet or something that you can use to connect to the internet, then you can follow along. If you don't want to, you can sit back and relax. To follow our presentation, there's an easy way to find the resources. If you go to a website called postcursive.com, if you do that on your phone or on your tablet, it will take you to this page, and once you get to this page, we just sent out a tweet that has a link, and it looks like this. So once you get to postcursive.com, if you check our Twitter feed at the very top, there's a link that will take you to the resources that we're going to use to present today. So I'm going to click on that link and we can kick it off. Our principal, Mr. Arriaga, wasn't able to come today, but he has been a fantastic leader in this whole computer science endeavor. He's been an enabler for Jose and myself to create an innovative curriculum and given us an awful lot of freedom and responsibility and leadership opportunities, which we fully embraced. I remember my first observation, Mr. Arriaga came into me, and it probably wasn't my best one because it was my first time teaching and getting observed. But what I remember him telling me was to go ahead and sell it, because I had always been passionate about technology, and in the classroom I was holding back. I was thinking, I can't get too excited, I'm just a teacher. I don't want to go too crazy with the kids. But Mr. Arriaga, during that observation, he told me, don't be afraid to sell it. And since then, I've taken that advice on board and become really passionate about teaching computer science. And my colleague, Jose Frausto, brings so much to the table. He's got so much experience as an educator and as a computer scientist, and he's really passionate about it as well. And with that, I'd like to introduce Jose Frausto.
Yeah. Hi. So my name is Jose. I've been teaching for about 14 years, since 2001, actually. And I've been teaching computer science for 2 years. I'm not a programmer. I didn't go to school to learn programming or computer science. I actually went to school to study broadcast journalism. But I do like Arduino circuits, and I do like coding and technology and web design. And so I think that's something that our principal saw, that he knew I was doing technology in my classroom. My fourth graders were coding circuits themselves as one of our centers. And so I think he saw that I had a passion for technology and pulled me out of the classroom to teach technology. And one of the things that I think he's done that's helped our program tremendously is we have 2 technology teachers, but we also have a separate tech coordinator. So we're not really dealing with fixing people's computers, setting up networks. We're really allowed to just focus on our curriculum and our teaching.
And my name is Jonathan O'Sullivan. I'm from Ireland originally. About 5 years ago, I was getting my master's degree in education from Chicago State University. And one of my professors mentioned to me that the most important thing you can do to improve your practice as a teacher is to reflect. So with that in mind, and this opportunity for us today, I took time to reflect on what we've accomplished in computer science. And we've made tremendous gains. Our students are really excited by it. It sells itself. It's easy to implement. And Mr. Arriaga, our principal, has given us opportunities to reflect on what we've been doing and then make little changes accordingly. So our program is constantly iterating, and we're building out this really exciting computer science curriculum. And I think just reflecting on your process all the time and changing things really helps in that endeavor. And this resource we have today is a website that we built using Google Sites, and it kind of takes care of the program for today. So we're just in the introduction section. At the very bottom, we have a link to Padlet. And Padlet, if you've used it, you'll know that it's an interactive space where you can collaborate and share ideas and share resources and share links, and that's exactly its purpose today. So this space is opened up to all of you. You can double-click or tap, and you can write something, share a link, share a resource, things like that. The only thing that's on there right now is a link to some reflection data, and you can click here to see the data. Right now it's empty because on the theme of reflection, during our presentation today, you'll have a couple of opportunities just to reflect and maybe share those ideas out using a Google form. So we've talked about the introduction section, and the website has everything, and I'm just going to start at the end. We've got the summary section, which we'll cover right at the end. Before we get to the summary section, we have a build and sustain section where we're just going to talk about how to build the program and sustain it over time. Before we get to that, we're going to have a little plugged session where you get a chance to use your device, or probably maybe team up with someone if you want, but get a chance to actually get hands-on with some of the programs that we're going to describe today. Before we get to that, we will talk about getting up and running, what it takes to start it in your school, what it looks like from a student's perspective, and what it looks like from a teacher's point of view, just starting it and setting it up for the first time. But the very first thing we are going to get to is our unplugged activity for today. And with that, I'd like to hand it back to Jose.
Yeah. So computer science doesn't necessarily mean that you have to have computers. So one of, I think, the problems or hindrances sometimes is, what if I don't have the equipment? What if I don't have the technology for my students to be doing computer science? So code.org actually has a bunch of activities that don't require any type of technology. And so there's a link right there that if you go down, you can see, and they're all divided by topic. So your teachers can actually just get a lesson plan. So depending on how comfortable they are, they can go in there, tweak it themselves, manipulate it any way they want to, or if they're not that comfortable, they can just follow the lesson plan that's already given there for them. And there's videos for them to look at it if they've never seen it, if they're not too comfortable with using the technology. And there's even handouts. And if you can go back to the regular page. And so if you go down a little bit. And so it's set up by the concept that they'll be learning, the lesson, there's a video for the curriculum, and any other resource that the teacher might need for that particular lesson. And each lesson then is divided by telling the teacher about how much time it should take. So about 15 minutes to get started, and it has vocabulary. Everything is built there for teachers. But again, if your teacher's much more comfortable, they can kind of just use that as a jumping start. But if they're not, they can really just go there and have everything given to them. And there's even an assessment for them. There's extension activities. So if one of the issues that occurs is some of the activities between course 1 and course 2 are very similar. And so teachers at certain times say, oh, my kids already did this. But there's extension activities that you can use to manipulate to kick it up a notch if your kids have already done it. And so today we're going to start with an activity about computational thinking. And it's designed for kids ages 10 and over. So this will be kind of like, are you smarter than a 5th grader challenge for you today? So we have an activity sheet that we're going to pass out right now. And what I like about this activity is that, thank you. It is computer science, and it's going to go about creating algorithms, but it's really just problem solving. It's not just computer science. And a lot of computer science education really, especially in K-5 level, is about problem solving and how to continue through a problem until you get to a solution. Because in code.org, I mean, they are programming, but especially in course 1 and course 2, they're kind of just making things move around. And really, it's more of the problem solving that's occurring there. And it's once they get to course 3 and course 4 where they're actually developing their own programs or their own algorithms. And so the only real instructions, if you look at the top line, is that there are no instructions. The instructions are missing from this activity, and there's a sentence that's been given to you. And so if you can go back to click on the activity sheets.
Okay.
Thank you. And so for this, we're going to need you can talk, you can get up. And one of the things that I like about computer science is that it's good for students that like to talk, like to be social, but it's also good for the kids that just want to zone out. And for me personally, I'm the type of programmer or coder, I like to zone out. I like to be by myself, nobody talking to me, and just moving things around. And my partner, Jonathan, he likes to talk about it. And so it really meets those needs of those students that need to socialize and interact to problem solve, and those students that just want to be left alone and do their work.
Now, the PDF document is taking a minute or two to come up. On this resource, there is a random number generator because it's the activity will ask you to use a die. But in lieu of that, we've created a digital one where if you click on the link, you can just spin the wheel and it will come up with a number between 1 and 6. So you can use this from your phone if you don't happen to have a die with you.
So if you look at the instructions just say, figure out how to play this game by looking at the player's phrases below. Circle the matching parts, which are kind of our constants, and underline words that are different from player to player, which are our variables, the things that change within the program. The first matching section has been circled for you. So we can see that on all of them they say, I choose, I choose, I choose. Now, I'll help you with this first one. If you notice, the first one says, I choose a lion, I choose a donkey, I choose a puppy. If we look at the second page, there's the donkey, there's the puppy, there's the lion. And if we look at the back of the first page, there's 3 different groups. Each one has a number. And so I guess we're going to give you about 7 minutes or so to kind of try to figure out this algorithm. And so we chose this activity because a lot of times when we're looking at code, we have no idea what this code's supposed to do. And we're telling the kids, figure out what it's supposed to do. So you can feel free to talk, move around if you want to. Do you have a timer? Cool. Oh, I have a drink. Thank you.
If it's slightly confusing, you feel free to check in with the person who's closest to you, maybe see what they're doing. You can discuss it with anyone.
If there's any questions or anything unclear, feel free to ask.
You have another one? Thank you. Pencils.
Long answer. If you need a pencil.
Okay. If you need a pencil, just raise your hand. We have lots of pencils as well.
Ready?
I think we're okay. Thank you.
Thank you. I think at the end we should say about our innovative program of the year from last year and the CS for All contest that our kids like. I might mention. And so the goal, once you figured out kind of what they're doing, is to create your own sentence, your own phrase.
Yeah, you might. I don't know. Would this be a good time to explain the value of it, or what do you think? I wonder, is that how much time we have? For the elbow
About 2 more minutes. I might just reiterate like the reason why I like this. About 1 more minute.
The kids at school, I was told them if I took some pictures, I'd put it on Padlet because they were asking. Showed them we went here yesterday using Google Earth, and we came into the building, and they took 360 shots from some parts. You can't walk around, but you can get some 360 shots.
Well, one of the reasons why I like this activity is just the problem solving that occurs, the computational thinking, the algorithm. It's an algorithm in an abstract sense. There's things that need to be taken out, things that need to be substituted as variables. And I also like that it doesn't have instructions. Because I find with technology and computer science, the more I get out of the way, the better it is for my kids. The more I give them a chance to problem solve amongst themselves and I'm not there, the better it is for them. And really, I'm just there to troubleshoot, to help settle any kind of disagreements on a solution, but it's really them that are solving everything. And so is there anybody that's feeling brave or that came up with a new algorithm? And our students would be given more time to do this. Our students would be given about maybe 20 to 30 minutes to be able to do this activity and create their full statement, but because of time, we wanted to shorten it and condense it for you all.
Right. So now we're going to give you a couple of minutes to share out with your neighbor or someone you want to talk to maybe about how this how you feel about this activity, how you see it might relate to computer science, you find it interesting. After 2 minutes of partner sharing, then we have a little reflection where you can write down your ideas, and those ideas will be shared with the group. Your 2 minutes for partner sharing is about to begin. Hopefully, in theory anyway. In practice with Google Hangouts, do you use Google Hangouts a lot? The Google Hangouts thing? Okay, yeah. I've heard of Zoom. Yeah. I found it inconsistent, but it's cool. So at this point, we're moving on to the Google Form reflection. And what that looks like is if you go to the webpage postcursive.com and you follow the link on Twitter, you'll get to our program for today, which looks like this. And at the bottom of the section for Unplugged that we just went through, there is a reflection button. So again, if you joined us later, or if you want to do this, you can go to postcursive.com, click on our Twitter link, click on Unplugged, and click on Reflection. It is a simple Google form. It just asks you to choose a topic for the reflection, just as a prompt. If you would like a prompt, there's the Unplugged, Plugged, Up and Running, or you can choose other comments and thoughts, and it just has an empty paragraph field for you to share your ideas. As soon as you hit submit, you will be able to see the responses from everybody. You can also check the Padlet space to see these same responses. So your ideas that you share, we're going to share together as a group. Let's set a timer for 3 minutes for you to do the response, please, if you can.
Just repeat the link.
How to get to the link? Absolutely. So to get to the link, the first thing to do is probably to go to postcursive.com. No problem. And from there, the link is on our Twitter feed at the top. And then it's just Unplugged and Reflection. Opportunities for you to provide reflection during the presentation today. If anyone is having any trouble or needs any help finding the resource or any kind of troubleshooting, Jose and I can help as well.
So that concludes our section for the unplugged activities. There are a lot more activities up on there, but I hope you could see how easy it is to be able to kind of accommodate or adjust these lessons depending on your student's ability or grade level. I mean, you could add another sheet with more choices. You can eliminate some of the choices, one of the sections. You can rewrite the algorithms that are there, condense them for students, just depending on their level or where they're at. And now we're gonna kind of show you what we did to get this up and running. What do our kids see when they're walking into our rooms?
So the first place we're going to take a look at is the student view. This is what students see when they come into our classroom or if they visit our classroom from their devices any time of day. So we've created a website called tantitech.com to facilitate all of this, to house the coding. And they can click on the big coding icon right here, which takes them to a page where they can find their login information. We've it split up by year of birth, and when they find their year of birth, they can either search for their name manually or do Command and F, so we teach them that skill, how to find text in a big web page. They can click on their name and then select their password, and they are in. The passwords are simple to remember, so it's very easy for students to access. When students sign in, they can go to their Code Studio page, and it has all of the different courses that they're taking at the moment, and it has a lot of other options, lots of different options for students. Maybe they're stuck in something, they can take a break and jump to a different activity. When they find the course that they're currently working on, they can continue their work, or they can take a look at the levels that they've completed and work on any levels that are most appropriate for that time. This is just an example of one of the most introductory levels. So that kind of just shows you really quickly what it looks like from the student's perspective, and that's what students do typically in our classroom as far as getting up and running. When it comes to setting it up as a teacher, it's quite simple. I'm happy to report that it's very, very easy. All you have to do is get your class list, and you can copy the list of students' names. There's an example going on right here where we're copying a list of student names. We're going to go to the code.org webpage and use the teacher sign up to create an account. I already have an account, so I'm signing into my account. And in my account, if I click on student accounts and progress, it shows me all of the different sections that have been created in the account. Now it's loading them right now, so it's taking a little bit of time. Initially, we used class room numbers, but as students moved from year to year, the room numbers became obsolete, so we decided to go with year of birth, and that's been a fantastic success. No more headaches. It works great. Kids can continue regardless of what grade they're working in at the moment.
Or which group they're in.
Right. Yeah, so they can progress between different levels once they can sign in with their year of birth. Right now we're creating a new section, calling it Coding PD. We're going to choose the login type as a picture. Very easy for kids to remember. Then you can choose your grade level, whatever grade you're creating the account for, and assign them a course to kind of start off on. Most of the time, you might be looking at course 1 or course 2 for elementary school students. Once you do that, you can hit save, and it creates the account. To add students, just click where it says Manage Students, and that the list of students that we copied, now we get to paste them. Just add multiple students and paste in all the names and hit Done, and it's pretty much done. Just hit Save, and all of the names they'll automatically have passwords generated, visual picture passwords that are easy for them to remember, and you can reset them easily as well. At the bottom of the page, after you've set up your account and your course, you can either print out the students' login information. If you click on it, it shows them their password. It gives them a URL, and it's just a way to give them something so they can look at it and remember their password. They might only need it the very first time. It also supplies you a URL, and this is how hard it is to get started, is just to share that URL with your students. So we've copied this URL. We've created a website that kids all know how to go to, tantitech.com. Easy for them to remember, easy for them to click on the Angry Bird, easy for them to click their year of birth and their name, and they're right into this. So it's very easy to set up as well. And with that being said, we are opening it up for any questions you might have on what it looks like from the student's point of view, or the teacher's point of view, or any questions you might have about implementing this. If there are any questions, we can maybe answer those for a few minutes.
Yes. Every day. Well, our students come to us, we're on block schedules, so I'll have a group for 6 weeks. So the 6 weeks that they're with me in particular, I'll do 10 minutes. When they get there for 10 minutes, they'll do coding every day during those 6 weeks. What we found, though, is that even though once they stop coming to us, they're still going to their coding. They're still doing it outside. And so even some of the teachers now in their classrooms, students that finish early, students that are a little bit ahead of their peers, they'll tell them, oh, go to coding.
And in my classroom, I do rotating technology centers, and one of them is consistently coding, so kids will get a chance to do it, for a long time, at least once a week. And they also have the option to forego their other center to do coding, because coding it's kind of a cornerstone of our technology curriculum. It's a good place to base things at and build a curriculum from computer science.
Just go back to the student before a minute.
Yes. The video itself?
Yeah, so you can show us that again, what the student will see.
Yeah. Now, we have different ways of students accessing coding. This isn't the only way. Both Jose and I each have our own websites built where students can access coding. We also have QR codes set up so kids can jump into different levels, which might be more appropriate for our kindergarten students, because getting them set up with an account, I think for us, we're just exposing them to the programs and let them explore it first. We've been kind of pushing more the account setup in first grade. We found it to be a little bit more practical. Yes, sir.
That website creation, I know that basically we have, our own website for the school, but if we want to create a website simply for tech, is that part of the hosting that CPS supplies for us as well?
Well, the easiest answer would be, I would say, use a Google site, to be honest. A Google site they've improved it tremendously since the start of the year. Yeah, and it's great, it's simple. It's a great solution, to be honest.
Okay.
Yeah.
Thank you.
Yes, sir.
Is this curriculum that you have here, like this, where is the largest part of this?
Where is it in terms of how much of the curriculum does it take up? Or
No, like where to find it.
Code.org?
Yeah, the coding curriculum is on code.org.
And then do you guys modify it based on your classroom needs?
Yeah, we modify everything based on our individual students' needs, whether it's them working through different levels or working with little small groups or working with somebody, or, there's so many different ways that you can facilitate this course and these activities, yeah.
If you have teachers who are interested in being trained on it, thank you. I'm a code.org facilitator in addition to being a CPS computer science teacher. The trainings for teachers are full day and free. They get the actual curriculum manuals to keep. They are trained on how to set up their classrooms. They're trained on how to do the unplugged lessons. They do some of them themselves, and it's a super valuable experience. So if you're interested, find me. I have a flyer. I've got 3 workshops coming up, May 20th, June 10th, and June 17th, all being held at Audubon. So let me know if you're interested.
And teachers get paid, right?
Teachers don't get paid
Anymore?
anymore. They used to, but they do
Yeah.
get CPDUs 6.5. And it's a not to toot my own horn, but everybody who comes to those workshops, because the materials are so well prepared, they walk on there. That was so much fun. And I think it alleviates any of the anxiety that a lot of teachers have, especially elementary school teachers that don't know anything about computer science. They walk out having the tools and feeling confident that they can go back.
Move on.
I don't, so I'm going to try to have maybe some printed from here.
We'll supply the BDs for you before you leave.
So, was there another
I
question?
think there's one more.
So the example you showed us in the video was it was the moving the elephant picture. Like, at what point in the curriculum do students do, like, when I think of coding, I think of numbers and semicolons and putting things together. At what point in the curriculum do they start doing that type of work? Just so we can be more informed and talk to parents about this.
Well, the code.org, the fundamentals, like the code with that you're talking about with like the semicolons, that's all hidden behind. And so they're really only moving blocks and doing those puzzles. That's like the first level of course 1. So most kids will get past that within 15 minutes. And then everything else it's all GUI based, which means it's blocks, but there's a button after each level that says show code, and that's hidden behind it, the actual typing. They don't ever really type in the fundamentals, their full code, but what they will do, they'll do number manipulation. If they're doing a shape, they'll have to know that loop it 4 times, and for example, a square, it's 90-degree angle, so they'll move forward 4 times and turn 4 times. And they'll put those blocks, and they have to put in 90 degrees and know that it's 4 times. So they'll have to know the math and the number sense of it, and external angles, and know those kind of things to be able to manipulate the objects. But really typing the actual code, it's not going to happen until I think they get to the 6th grade one, and they do the other versions of it.
Yeah, they're just learning the real concepts behind it, the building blocks, and I guess when they're more ready for it, they'll probably be learning the actual coding itself, picking languages. But we're going to move on for now to the next section, which is our plugged activity. And it starts off just with a brief little, I suppose, talk about blended learning and what that is and why it's so important. And blended learning is essentially like this PD that we're doing today. All the resources are online for you. You can access them as you want, anytime you want. And our kids today, they're a special generation of students, and this is kind of how they like to learn as well, just like us. They like to have convenience, they like to be able to work at their own pace, and they like to have their learning personalized to themselves. And blended learning, I think, facilitates that a lot, and it transforms the nature of the classroom. I remember when I was back at university, I did a little talk for a school about using iPads, because I went to grad school iPad only. I wanted to go paperless. I said to myself, you know what, if you're going to do it this way, or go for it anyway and see what happens. But I remember during that PD, I told the teachers, I read it somewhere, that a teacher who implemented blended learning couldn't believe how much free time they had in their classroom. That was the biggest obstacle, was, well, now what do I do with this time that I have? And I said it to the teachers, and I got a little bit of a weird feeling, because I didn't know if it was true. And I really wanted to know if that was true. So being a teacher now and using blended learning every day in the classroom, I can attest to its transformative nature. And it takes a teacher from maybe being directing the classroom all the time to be more of a facilitator and coaching the kids in and out. And it really transforms the culture of the classroom. So when you walk into Jose's classroom or my classroom, I think it will look very different than walking into a traditional classroom as well. And Jose, if you want to mention about, we'll go to code.org.
Yeah, so now we're going to go to the plugged activities. So just on the website, if you follow the link that says plugged.
Let me jump here. Yep.
And so now we're going to give you a few minutes to actually practice some of the code.org. So the top link takes you to the main fundamentals page, where everything is housed, where all the curriculum, all the courses are put together right there. And if you go back, and then beneath, we have the actual courses. So depending on your comfort level with coding, if you want to try real basics, start at course 1. If you think you know a little bit, go to course 4. Some of the math that the kids are doing, I have a 2nd grader who has to know now how to find area perimeter, because he's on course 4. And some of the things that he's doing there, they're way beyond what he's learned. He has to do multiplication. He has to know that 5 times 72 is going to give him 360. And so I have to take the 2nd grader now and put him to the side and show him how to use an online calculator to get that, because none of his peers are doing multiplication yet. And so if you think you're comfortable with it, you can go to course 4. Or if you want to explore the different topics, I try to pick a course that would show you how the kids are doing algorithms, conditional, sequence, loops. There are even some where they're creating stories or creating their own versions of Flappy Bird games. So I guess we're going to give you about 8 minutes, 10 minutes.
Yeah, we're going to set a timer right now, so you've got time to explore that resource for 8 minutes. So please, if you have a device, go ahead to the plugged section of the website. If you don't have a device, maybe just team up with someone and take a look at what they're doing, ask them what's going on.
And can you click on one real quick?
Yeah.
And one of the beauties of code.org is that it's accessible to any student regardless of language. And if you go to the bottom of those activity pages, there's a section for language. So, and there's like a plethora of languages. There's languages that I don't even know existed, but students can explore.
Are you talking about for
right there, for the activities?
Oh.
At the bottom right there where it says English.
Oh, yes, I gotcha.
And so we work primarily with ELLs. So our ELLs can go and do this in Spanish.
If you need any help finding the resource, we can help. Sphero's next.
These are mostly K through 5. They have the H's right there. So this is what we primarily use for our K through 5 curriculum. And then there's algebra. It depends on the student. I mean, I have we'll have 12 weeks with us. So within like those 12 weeks that they're with us, I would say about 80% of them can get to yeah. And it also depends on. Hi, Todd, how are you? Because in course 1, if they need to go left, they just pick the arrow that goes left. In course 2, they actually have to tell them turn left and then go forward. Yeah, and so that dynamic changes. They're thinking of
We do it
space.
because we spend about, out of 45 minutes in the classroom, typically up to 15 or so is coding, and the rest of the class is different then, because it's not all our computer science curriculum. It's a part of our computer science curriculum, so it doesn't take up the whole class. We do everything else. Yeah, we teach all the very important things that they need to know as well. So we manage our time,
Yep.
as tightly.
Yeah, like what I do is if I say kids, he's really struggling, or a few of them, then I might pull them in and do a mini lesson
Okay, yeah.
what they're struggling. Maybe it's the loops that they're not seeing, and pull them to the side to do that. But yeah, for the most part, especially like the kids that are self-motivated, there's very little I have to do. Yeah.
I did just add the link to Padlet as well, if you end up back there.
Yeah. Not. Well, we started with our third graders. So our third graders are our fifth graders. There's a lot that are in course 4. They might not get to finish it. We've had 2 already finished it, but for our younger kids, we have a second grade class where the majority of them are about to finish course 2 and get into course 3. So that group for sure, by the time they're in 5th grade, will finish it. Yeah, we started everybody in course 1. Yeah. then we do a lot of digital designing. We do web design using Google Suites and whatnot. But for the 10 minutes of coding, so just do 10 minutes every day. Yeah, when they get in, I have a little Google form where they check in, and then they go straight to coding for 10 minutes. And then depending on one of my observations, if I see somebody struggling, the next day I might have a mini lesson that I'll call in all of them or a certain group, just depending on where they're at.
It sounds like you've taken a look at all the various options that are out there in terms of the coding and so forth, the various programs, and you did design a structure of each course to fit those different needs, right? So you're calling it coding, you're calling it something else, you're calling it this. Do you have a syllabus or way that you'd be willing to share? Like this is, because obviously we're gonna have to figure that out, but if you've already figured out a way that works for you, it'd be helpful to sort of riff off of.
Our websites are pretty much, if you go to tantitech.com, and then we have Media Center and then Computer Lab, and we have a code that's just 101 that we use mostly to, because our kids sometimes post their images, and so we use that kind of as a protection for them so that people can't really see their work. Are you using your CPS account for the Google Slide?
So, ladies and gentlemen, we're going to move on. You're welcome to to explore these resources further at your leisure, at your own time, or in a little bit. We have, the next thing is Sphero. Let me show you this quick video that we used with our students to take this coding program that you just had a chance to play with and bring it to a bit of a more of a real-life application.
Sphero Battles. Welcome to the world of Sphero Battles. Here you will test your thinking skills to the maximum. Your objective is to get Sphero, your adorable colorful robot, from one box to the other, without knocking anything over, or veering outside the Sphero battleground arena. It might seem easy, but you might have some obstacles in your path, and you will have to figure out how to navigate around any obstacles. To make Sphero move, you can use the application Lightning Labs. Once you connect to your device to Sphero, and you must connect using Bluetooth, you can use the Lightning Labs application to give Sphero the instructions to move from one box to the other. This challenge is similar to the Angry Birds coding you do. But instead of telling an Angry Bird how to move around, you get to tell a real robot where to go and how to get there. This is so exciting. Good luck with Sphero Battles, and I can't wait to see what you do.
So Sphero is a little robot like this, and it connects to any device using Bluetooth. Jose and I, we both have young kids, so for my daughter's 4th birthday, she got a Sphero. And I bought it kind of a little bit for my classroom too, and just to check it out myself to see if it was something that I could use in the classroom. So I brought mine into the classroom. The kids are using it, telling it where to move around. They're programming a robot and executing these programs. Jose did the same thing. So we had a Sphero of our own each in our classroom. Kids loved it. We wrote some grants, and we were able to get 2 more that we use in our classrooms every day as well. And at this point, it is your turn to be brave. I think we've got a crowd, a size of an audience that everyone will get a chance to participate if you want. What we're going to do is give you an activity. So each of these stations here, there is an iPad connected to a Sphero. So you don't even have to connect to the Bluetooth. When you have the Sphero, you may have to, let me show you real quick on this one. You do get to choose a color. There's a color wheel. Whatever color you choose, the Sphero will change to that color. So you can go green, you can go red, you can go blue, you can whatever you want. One other piece of advice for this activity is there's a little aim button down here, because you get to drive it around using this. But if you press aim, what will happen is, and I'll just put it up here, it might be difficult with the lighting, but when you press aim, a little blue light shows up on Sphero. If you can see it, if the blue light is pointing at your iPad, then it knows that forward is forward. And if you push to the right, it will go to the right. If you're executing a command and expecting it to go forward and it goes backwards, your aim is probably off, and you can just change your aim anytime by touching the steering wheel or the drive button, touching aim, and pointing the blue dot at you. I would suggest every time you run the program, check your aim. It saves you some trouble. One other piece of advice is, instead of just driving it around like we tell our kids, you have to use programming. It will already be on the app, the correct app for you to use. If you click on Programs at the bottom, you can press the plus sign and press Create. You can give it a silly name if you want, whatever, as long as it opens up a new program space for you. To make it work, all you have to do is, where it says Actions, is choose an action and drag it up to the top. The best action to use is probably a roll action. When you use a roll, it's going to ask you for 3 different things. It's going to ask you for the duration of the roll. So maybe 1 second, because we're going to give you a small space. We don't have a ton of space. It's going to ask you how fast you want the robot to move. I pick about 100-ish, whatever you can experiment. And it's going to ask you what angle do you want the ball to go in. So for this, if we put the ball right here, and we press, once we're done, we can press Start, which is equivalent to the Run button. And let me just check my aim real quick. So the aim is good. It should go right ahead. As soon as I press Start, it should start to move that way. And it did. It went a little bit. So once you're done with one roll, you can add, then your turn is over, and maybe give it to your partner or whoever is next to you. And you can work together to add different rolls together to make Sphero navigate the obstacle course. The obstacle course, we've got 2 Legos. One you can put in front of Sphero as a starting point. One you can put a little bit away from Sphero as a turning point. So ideally, if anyone can do this, congratulations, you will be superstars. But all you got to do is move the robot around that other piece of Lego and back to the start. If you can do that, you win. Congratulations. So we've got enough for, I think, 5 different groups, Jose, is it?
There's 6.
Or 6? We got 6 now, yeah, because we got the other one working. So we've got 6 groups. We might have one group over here in this section. We might do the other one off to the side. Maybe we can put one in front, and then maybe we can do 3 up here on the stage. Please feel free to come up. It would be nice to have at least maybe 2 people working together on this. And it's a lot of fun. And if you want to try and do it, you can set up your own space. I got Lego. Oh, Jose already has the Lego out there.
Yeah.
Here you go. It's all yours. Yeah. You know what to do? You're good to go?
No.
Well, I'm going to get rid of my coding so that you can begin to create your own. Here is the robot. You can set up your own space, maybe from there to there, and work together to add commands using the roll option. That little roll button.
And then just take it up.
Yeah, so just take it up there, set the variables, press Start or Run when you think you're ready, and join in and have fun together. If anyone needs help getting set up or getting started, we can help.
Yep. So usually we would have the
Need
kids
help?
kind of
Well,
put it here.
Let me help.
And you go around.
So to get this started,
And
it looks
come
like
right
this ball has gone to sleep. Now it's waking up. So yeah, just like that. So it should connect when we create programs, a plus sign, and boom, 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 done, save. And now what will happen is
First
you
thing you
should
wanna
be
do
good
is
to go. It's
so you aim
connected.
it,
It's
so you
connected
wanna
already.
kinda turn
So all
it.
you got to do is choose an action. In our actions, we could choose a roll action. And when you roll it up here,
This-
now you can tell it what you want
So
it
you
to
run
do
out. There should be a
specifically.
blue light. You want that.
I'll
blue
put the
light
robot
to
on
point to
this
you.
ball, or on this side if you don't mind. And if you can figure out how to get it to
Actually,
move
first,
around and back, you'll be superstars.
Yes, right now we're teaching it that's forward.
Yes, it's definitely easier. Yeah, you do whatever you think will work.
And so if you want to give it a name, it's whatever you want to call it. And so your blocks, your actions are all right there. So the roll, there should be a turn. Yeah, so you just can. Yep, and you just drop the blocks.
They're about $100 typically,
Yep,
$100. You might get them $20 less around November for Computer Science Week. Yeah. Where do we get them from? Yes, lots of people have them. You can get them from Best Buy, which is a CPS vendor. Tons of places have them. Any Target, any place you walk into, a lot of them have these.
It's just the actions. Well, instead, to turn it, you would tell it the direction.
Okay. There are CPS vendors that sell this, yeah. It's called Sphero, Sphero. Yep.
Do you need help?
And you can feel free to grab the ball, move it around.
Did you aim it already?
Thank you.
Okay, so then just inside, groups, and plus sign to servers. So yeah, we're gonna use the blocks. And then if you just want to give it a title, a name. And so the actions will be right there. And you just drag and drop the top.
You know what? It looks like it went back to sleep. Let's wake it up again. Give it a little bit of a. This one might have low battery. We tried our best to make sure they didn't turn on the way here. Give me 1 second. I'll try something.
Yeah, these are a lot of fun. When I first got mine, I was just playing at home with my son. They're about 100.
Okay, hopefully.
But these are really popular with donors choose. Because we've each got into other ones.
So
based
it
on
won't.
donors choose. That we're going to tell them at the end about how you
disconnected. So now we'll try and reconnect. So what we'll do to hasten it along is aim it or try.
We love people. We love
Now
talking
it
about
will
this
be
stuff, so
prompted to reconnect, and hopefully it does. If it doesn't,
thank you.
well, actually, it kind of runs in the background itself. Yeah, you could do that what you just did, but it should just take care of itself. Yeah, it just is, and it usually connects to the same device. Now, typically it works rock solid. It does. Occasionally, you might have trouble like this, and there are ways to troubleshoot it. But because we don't have a ton of time, it might be difficult for us to go through all the different troubleshooting steps. But actually, one good troubleshooting step is to turn off your Bluetooth, wait a few
Yeah,
seconds.
they do have
Turn your Bluetooth, because usually
some
it
issues
flashes.
with batteries.
Flashing.
The nice thing with
it's not
Sphero is
connected.
they'll replace it for
When you
free.
turn on your
No
Bluetooth,
questions
it
asked. They
establishes
don't even ask to look at
connection.
your receipt.
It stays a solid color.
You just call and say, let me try
So
something.
it may do that now. It should. If it doesn't, might have be a little bit out of luck.
It should be.
Aim it again, right?
Yes, and now we have to go back to the aim. And then just move that circle until it's.
Was anybody able to do it? Did you guys get it? I heard some screaming from over here. You did, really? So do you think it? Okay. If
I'm trying to see if there's something
really,
in the
well,
program
that's
that's not.
great. If it works, because it's computer science. Once it works
Oh, I
once,
think
if
it's-
you hit run,
yeah,
it
I
should
think,
happen
yeah,
again. You
that's-
know. So with that in mind, if you can do it, I will broadcast it to the group.
It's
you know,
really sensitive
using
though.
Mirroring.
Yeah, so since there was no speed,
When you bring out the camera, things never
going at 0 miles per hour.
Very good. You can drive it back as well if you. It's gone away, but to get it back, all you have to do is touch the drive thing, and you should be able to drive it. Which way is it going? Maybe it's this way. It looks like the aim is off a little bit. So check your aim. When you touch the aim,
Yeah, it's
button,
still running
the
its
blue line is pointing
through
at
its
you,
whole cycle.
like it is right now. Then forward will be forward. No problem.
And so then every time you pick it up, you do have to re-aim it.
Yes, you do. Right. Well, yeah. This is their first time doing it. It's just giving them a chance.
I think so, but
see it. Yeah.
we
I
got most of
figured,
ours through
yeah.
Donors Choose. Like we just bought
Oh,
our
yeah,
first
yeah.
one, and people on Donors Choose love to like pay.
Well, that's how it all starts.
The white ones are 100, and then the ones that are clear, they're the educational ones, so the kids can see. They're about 120 to 130. But we found that donors, like when we put them at Donors Choose, they get picked up right away because I think people see them and they see the value of them right away. And well, we're using them as a tech teachers.
Oh, you know what? This one
It's
died.
one of our kind of
For some
our.
reason it just died. The battery must have run out. I don't know. Mustn't have. You know what? It's wireless charging and it doesn't replace. What happens is they're excellent. Their customer service is fantastic. I had my two spheros
if you
were
want,
dead.
if you want to
And
try the
battery wouldn't charge. I called them up. They said, "Oh, no problem. We'll send you out 2 new ones." That's exactly what.
Go for it.
So now I got 2 brand new ones. Yeah, and it was way outside of the. They didn't ask about when I bought them. I told them, you know, I'm a teacher. I use these, and he goes, "We'll take care of you." We had me run through some just testing, you know, to see if it would get a charge. Didn't get a charge. Said, "No problem. I'm sending you 2 new ones. Just send the old ones back."
So he probably already asked this, but how much?
They're about $100.
For us, this is also just an
Maybe less
extension. We're
sometimes.
seeing the
20
blocks.
bucks less, maybe
I
sometimes.
mean, it's so abstract, just moving blocks. And
Well, we have 2 school ones and one
But
of our
then now
own.
they
so we've
see,
got 3
okay,
each.
these actually do have an application in the real 3D world.
Well, no, this is mirroring. Yeah, just I was because if anyone was able to do it, the next generation will. Yeah. But if kids do it in the classroom, if they navigate the puzzle, well then I record it and we put it out on. Yeah, we send it out in a tweet, you know, typically or something like that, so they get their.
Yeah, I recommend. I mean, the same thing. Like if you go to a PD.
Alrighty.
I mean, because I was trained by myself for like months, and I'd gain a little bit of knowledge, but then I wouldn't trust him for 2 weeks and be like, well, what did? Yeah, I mean, yeah.
Okay, ladies and
They had a
gentlemen.
Minecraft Raspberry Pi. Yeah. And I was trying to build it, and we had a few kids
Thank
last year
you
try to build
so
it.
much
And then we had one of our
for taking the time to get up and move around and use Sphero. We have about 10 minutes left and we've just got a couple of more things to get to. If you want, you can just leave the Sphero on the stage anywhere and the iPad's on the stage. The Sphero robots, they cost about $100, maybe 20 bucks less or so they're not terribly expensive. And if the battery dies, it's wireless charging. The company is excellent about just switching them out and giving you new ones. They're very supportive of education, and they've been tremendous. For Jose and I, they've given us replacement Spheros if we ever have any trouble, no questions asked.
Can you download the program on any device?
The program plays on any device. Yeah, including a computer. They just released Lightning Labs as well as I think it's a Google Chrome extension.
Yeah.
So you can do this sitting at your computer controlling a robot without using a mobile device. Yeah.
Can you give us an idea of how to order?
How to order
how we
Sphero?
got them, how we got the grades.
Well, we initially walked into Best Buy or Target and purchased our ones. CPS has a ton of vendors like Best Buy that sell them. We then did a grant application, a Donors Choose. Jose, if you,
And these are like, I mean, Donors Choose loves to pick these up because they don't go into the $200 range, and they're usually about $100 to $130. And so we found that, I mean, we started with 1 each. Now we have 3 each in our classrooms, and they've been given to us. So it's really easy to get more. You just have to do Donors Choose, grants, and they're easy to get.
Right. We don't have a ton of time left, so we had the reflection opportunity again scheduled in here with the 2-minute partner share and the Google form. But because we're running a little bit tight in time, we might forego that. You are free to go to the bottom of the plugged page and click on the reflection form now or later if you want to leave a reflection on this particular activity. The next thing on our agenda is to talk about building and sustaining momentum, and Jose is going to run through that.
Yeah, so I'll just go through this section really fast. So for us, this is our 2nd year that we've had our program running. And part of what got our kids really going was doing Hour of Code programs. And in December, it's this pretty much global now movement. And if you can get some kind of hype, so we do events where we have people Skype, FaceTime with us that are actually doing coding, and they talk to our students about how they do coding in their jobs, in their fields. And I mean, she was in Ireland, wasn't she?
She was in Ireland, yeah.
Well, when we Skyped with her. So our kids are able to talk to different people and just get them excited and hyped up about how this coding is going to help them in the real world outside of school. And we've also created rewards. So after they finish a course, code.org gives them a certificate that they're able to print up, or we do them digitally. So we have Padlets where our students post their certificates. So they're able to, at the end, to see how they've progressed and show their parents at home on their phones or on any device what they've done. And we save paper. And we also have 3D printed Angry Birds. So after our students finish course 2 or course 3 or course 4, they get an Angry Bird. So right now I have a bunch of 2nd and 3rd graders that are trying to finish course 2 because they want to get it before the year ends. And we've done Edmodo badges, so we've also used Edmodo and created our own badges using pictures from code.org. And so we give those to our students when they pass. And we use Twitter a lot, so we'll go on Twitter and we'll post about our students' achievements, take their photos, and just so that they have a space to go home and show mom and dad, oh, look what I did, look at what I got. And it's there, and it's also a way for us to show what our students are doing. And we use different apps to try to bring in other things. I mean, code.org is awesome, and it's really great, but there has to be other stuff brought in, especially as your kids start exiting or completing all of the courses. So we have apps that we have for them to be able to use on iPads. We have after-school programs. So Mr. O'Sullivan has Technology Club. I have STEM and Robotics Club after school. So it's just our kids are just given more opportunities to extend what they're doing with us at other points. And Code.org kind of runs them. I mean, there's so much content, sequencing and loops that they experience. Go next one. They're doing reading, and a lot of it is actually reading. There's so many times where I'm walking around telling kids, there's no programming involved in this one. You just have to read. And there's just steps that they have to follow and just go step by step on some of them. There's no real computation. It's just reading and following the sequence of the steps. There's a lot of computation. I mean, this one right there, that's there, they're told the red one is 100 pixels tall. You need to make one that's 70 pixels shorter. And so there for ELs that are barely learning how to read English, there's a little bit of deciphering that they have to do. What does it mean 70 shorter? Is it 70 because it's shorter, or do I have to subtract? And so they're doing that computation there. There's angles. And for the younger kids, it actually shows them what the angle will look like so that they're not really guessing, especially if they haven't been exposed to angles. Their storytelling, as they progress, are able to create these little mini worlds where characters come up. They can talk to each other based on the code that they're putting there. And there's designs and different art pieces that they can do based on the code they're making. And most of those will happen around course 2, course 3 is when those start occurring. And then just again, trying to create more opportunities for our kids. We have different online extensions where we have QR codes that take them to specific places so that they're not losing time searching for things or just other websites that'll help them keep on doing coding. And then why do we do it? One of the big things is to get our kids ready for the job market. I mean, we keep hearing these numbers. Illinois is going to need this many people to know computer science. We need this many people. There's not enough African Americans, not enough Latino students involved. So we're just trying to create a space to get those numbers to go up.
I guess we'll forego this part to get to or maybe we can talk about the podcast. The stories of coding, we podcast a lot too. So like this example here, Karen, she's a 3rd grader, I think it was. 5th grader? Well, yeah. And she passed course 3, so lots of times we'll sit down with the kids and interview them or have other kids interview them, how does it feel? And we play these back, we shoot them out on Twitter. We have podcasts that the kids can go to. During the Hour of Code event that we have at our school, we play back a lot of these audio clips or we've got video clips. So again, kids love to talk about their achievements, and it's a great way for them to get that out there and share that with the school community and with their peers. And they can relate to their peers, and it's a chance for them to celebrate success. So it builds this whole culture of high-quality use of technology and computer science and coding.
Yeah. And I just want to add, we've become so motivated by just seeing our students. Last year, we were awarded the Innovative School of the Year for both of us, and that was our student success. That was them being coding. This year, CS for All had a contest in December for coding, and we came in 4th place. First place was Curie High School. First was Lane Tech. Second was Curie. Then Gwendolyn Brooks. Then it was Tanti. And you needed to log in with an email. And so our kids, it was really our 3rd and 5th graders are the only ones that are using email. So our 3rd and our 5th graders were competing with all of the students in Curie, all of the students in Lane, which are about 3,000 some students. So this is really, for us, it's really motivating, and to see that our students are so motivated because they couldn't compete if they were just doing that in our classroom. That was really them going on their own time after school whenever they were able to do this. We have a student who's got a cracked iPad, and he's doing coding whenever he gets a chance to do it. His iPad is shattered, but he's trying to do coding. And so we get really motivated seeing how motivated our students are about this.
And in summary, just to review from today, we talked a little bit about getting up and running to show you what it looked like from the student's point of view and the teacher's point of view, and then how to build and sustain a program, putting steps in place to go beyond just the hour of code. Really quickly, some tips. We use Twitter a lot to promote not only our computer science, but also everything we do in our school as a way to celebrate what the students are doing. YouTube as well, we've got a little bit of a YouTube channel going where kids are always anxious to create content and publish it on YouTube. We use Audio Boom. It's a free resource. All of these are free social media outlets or social networks. Audio Boom is free. We use it for podcasting. As long as the conversation is, 10 minutes or less, it's free. We use Padlet all the time in our classroom for kids to showcase their ideas and share their certificates, share what they're doing with us and with their classmates and also with their parents and their families. And social media has been a big outlet for us as teachers, and we use it all the time in our classrooms. Finally, all the resources for today are available on the postcursive.com website using that link that will take you to the webpage from today. The last bit of and we're out of time pretty much anyway, but on our webpage right here, if you want to give us any feedback about the presentation today, on the very last page where it says summary, we have just a little reflection. You don't have to do it now. You can do it anytime you want. It just asks you some questions about the presentation today so that we can hone our skills as well. If you have any questions, we may or may not have time.
And if you can put questions also on the Padlet.
Yeah.
If you leave an email, we can get back to you.
The Padlet will be there, and please feel free to share resources as a group there, and we can collaborate in that space.
Thank you so much, you guys. Isn't that awesome? And thank you for participating. I love it. So do you have any questions? Yes.
Post cursive right now, but what was the other? You said Padlet. I know that's an app, but specifically, what website are we going to?
If you go to Post Cursive on the Twitter feed, there is a link. It's the first link on the Twitter feed because we just sent out that tweet yesterday, and it has a link to the web page that has all of the resources for today.
Information. Okay, I see it. One more thing is basically, I know this is relevant to schools, but the BYOD, like bring your own device. Like I know, do we actually give the students the login for the Wi-Fi or whatnot when it comes to that? Because if they're going to go on code, they need access to that. So I'm just trying to figure that out. Because I do have students who actually bring in their devices like, hey, can you go ahead and put the Wi-Fi password? And I'm like, I don't know if I should, but I don't. So.
What do you guys do?
Yeah, well, I give it to them generally.
Well, we're K through 5, so we don't really have a lot of kids that bring devices. It's maybe a handful. And so I'll just put it in for them myself without giving them the password. But it's usually kids that I know that they're going to use it for doing work.
That's a great question, though. And that's something that we're going to have to increasingly think through. Mm-hmm. Yeah. Any other questions?
Is it possible for someone to come visit the school to see how their curriculum's being implemented?
I mean, we'd probably just have to ask our principal, but I'm pretty sure he's pretty open and we're open.
Okay, thank you so much.
No problem.
One more question before we break.
What about also visiting you?
But yeah, that's what I mean. We would just have to check in with our principal, but he's pretty open to and supportive of everything that we do. So.
And yeah, Principal Arriaga is an amazing visionary. These are cohort 1. It's a cohort 1 school, so they've seen the rotation. They've tried some things out. Definitely want to reach out because he's going to have answers. He will have gone there, as many of you are. We've got other amazing leaders here in the room. I really would love for you guys to talk to each other because you know what you know at your level and can share and encourage each other. And always feel free to reach out to us because we're only here because we are to serve you. Okay? So any other questions when we get back together at the end, maybe you can ask. Always, please do the reflection. We created this PD out of a PD we did for high school principals in February where we immersed them. They're coming this afternoon to be immersed in the high school curriculum and the changes that they said that that made for them. And so we need your feedback so we can keep doing this and maybe even do it better, okay? All right, so now we're gonna take a break. There are some snacks outside. Please go and have those snacks. And then what time will we get started in our next rotation? What time? 10:15. Thank you. I'm gonna go chase the last people in.
Okay.
Okay, we're about to start in 1 minute. So scarf up and grab a banana or whatever. This is going to be Project Guts, and that's the Apple Middle School around the corner. Okay? You're welcome. Apple Middle School is around the corner. Okay. Okay, 1 minute, 1 minute. Okay. In there, yes. I want some of this. This is good. Okay, I'm just leaving my cup right here. I'm just gonna go announce her and then. Okay, come on. Come on and join up front. Get close to the fire. Okay, I just had a brain burp. What's your school?
Hamilton.
Okay. It's, the brain just drained down to my shoes. Okay, good morning. Okay, now you're in for the next treat. We have Carrie Rovito, who is from Hamilton Elementary, and she's going to teach you about how we teach computation in the sciences. And so without further ado, I turn it over to Carrie.
Hi, everyone. My name's Carrie Rovito, and I have been using the Project Guts curriculum for the past 3 years in my class. And I've also have been doing teacher trainings for the last 2 years. And so I just wanted to start off by saying if this is something your teachers are interested in, I would recommend that they go to a training because unlike the code.org, which is very student-friendly, Project Guts can be very frustrating if you're going into it without any background with it. We do have a lot of resources that are available online, and there are a lot of YouTube videos, but it becomes a lot easier if you do go to some of those summer workshops to just kind of be able to work your way through. So, as we start, why do we need to teach computer science in science? And so it's really great when you look at some of the other computer science learning programs that are available online because it does get students used to doing that computational thinking. I was sitting in on the last session and one of the principals had asked, why are students using block-based coding? And something that we always tell the teachers during our trainings is because computer languages are changing all the time. And so it doesn't make sense to teach really young kids computer language at this point. We want to get them used to using logic and problem solving and seeing how different loops work and see how block-based coding can do that without having to worry about misspelling words or worrying about where you're putting an apostrophe or where you're putting or how you're like changing lines. And so just like code.org's curriculum, Project Guts also uses block-based curriculum, but it takes it to the next step. So code.org does it where they show you how to get through mazes. As you get to more advanced levels, it does have you play games like Flappy Bird, and it has you start to write different programs that you could use with like an app. But Project Guts says, here's how you can take that and make models work for science, because models are used all the time in science to predict what's going to happen. So it's used in all science fields. Project Guts focuses on physical science, life science, and earth science. There are 3 modules that are already built in that have to do with water resources. There's also an additional one that has to do with greenhouse gases. The life science module focuses on epidemics and how predator-prey relationships work within an ecosystem. And our chemistry unit focuses on how chemical reactions look at a micro level. But after students go through and do these modules that are already built in, teachers are free to create whatever modules they'd like that kind of explore using those concepts they've already learned. So it's just another way of conducting experiments and collecting data. So I can give you an example of how I use this in my class this year. I am a 6th through 8th grade science teacher, and in my 7th grade class, we were seeing how diseases spread throughout a community. So we did the labs where you see how glow germ can be spread on kids' hands just like the flu. So we went through and we did an actual lab. But then we saw we only have 28 kids in our class. How does this really look in a city? So they were able to go through and build an epidemic model where they were able to manipulate how many people lived in my city, if there were people that were vaccinated in my city, what the transmission rate could be of a disease, and how quickly a disease can rise, and then once people have it, drop back down. And that's not something that can be done in a normal science classroom using just the students that we have. So it relates what we're doing in the classroom to real-world situations. The content for Project GUTS aligns to the next generation science standards, and in the curriculum, it gives teachers a layout of exactly which science standards are being met. Engineering standards are also tied in to many of the different lessons. It builds on skills they might be exposed to during Hour of Code and any prior computer science exposure from previous classes. I would say that Computer GUTS is most like, from what I have seen, Scratch. So if your students have used Scratch in their classroom, or if they have gone through and have started using the Project GUTS, the code.org lessons, none of this should be new to them. So it's all clicking blocks into place and seeing how they affect each other. Part of the computer science continuum is that CPS is pioneering and will prepare kids for high school computer science classes. A lot of my high school a lot of the kids from Hamilton go to Lakeview High School, and they have said how much this has prepared them in their computer science classes. And so it's really nice that they have that foundation. They are really curious about learning. I guarantee you it'll take your teachers more time as they're going through the lessons to figure it out than the kids, because the kids have really, really embraced this and are excited to learn. And they're really excited to manipulate all the different lessons. So, if you are going through and using this in your classroom, you will need 2 different websites. For the teachers, they will need projectguts.org/resources. And that gives them the curriculum, and that gives them different PowerPoints that they can use. It gives them pre-tests. It gives them examples of how they can use rubrics to assess students. So that is what teachers would use. And so if you would like your teachers to start looking at this before a training, this would be the best place to start. The other site that they will need will be where the coding actually happens, and that is slnova.org. SLNova stands for Star Logo Nova, and it is based through MIT. So Irene Lee, who's one of the creators of Star Logo Nova, works at MIT, and so she'll be one of the biggest resources you can have, and I'll give you her email address later on if this is something you would like to use in your classroom. So I'm going to tell you a little bit about what some of the modules are, and then we're going to do an unplugged activity from one of the modules. So to get started, students will be doing Module 1. This module is designed to introduce students to coding so that they complete the content area models. They will have activities that are plugged and activities that are unplugged. So plugged activities will need to be done on the computer. Unplugged activities are walking around. They're using pencil and paper, so students understand the concepts before they go and do the computer programming portion of it. If you like, we can, or a little bit later on, you can see a checklist and links progressing through Module 1. But Module 1 is just getting students used to using the computer. So it is a little bit different from Scratch. It is a little bit different from code.org. So it's kind of just getting them used to how this computer system works and how it's different. So all students who are going to be using this should go through Module 1. I'm going to have you do an unplugged activity from Module 1, and the purpose of this activity is so that students can see how headings can change as you go through a program. And so what that means is that when you are going through and doing your paper in just a minute, you are going to have to pay special attention. You need to turn the paper, if this is not something you've done before, but this is how I have my students do it. If you are being the student and doing this, I have you turn the paper because you are going to imagine you're traveling in a straight line. And from there, you need to decide, are you going to turn right or left? Then, after you have decided if you're going to turn right or left, I would have you physically turn the paper again so that you would be walking forward. So you want to imagine that you're always going forward to determine if you are choosing between right and left. The objective of what you are going to see on this paper is for you to collect all of the treasure. So you are going to start and stop from the same block. You are going to only travel in straight lines. You are only going to make 90 or 100-degree turns, and you should draw your lines in the middle of the boxes. When you do this, you should avoid all of the obstacles. So here's the important part. I want you to do this first with pencil very, very lightly, because you are going to be coloring in some of the squares and then erasing your line. The purpose of this is having somebody else next to you be able to take that exact same course by just looking at the colored blocks. So for example, if you are going forward and you see that your line needs to turn right, you would color that box red. So right is red. Then, if you want your line to turn left, you would color it blue. So then you would color that box in blue. If you wanted to go backwards or take a 180-degree turn, you can color it black. So the only thing that should be on your map after you're done are colored boxes, no lines. So you're going to erase the lines and give your paper to somebody else to see if they can solve your maze. Does anyone have any questions about that? And the instructions are at the top as well. So we'll come around and hand out your materials.
Carrie, what do they need? They need a red and
They,
a blue.
a red and a blue, and you can even do that per partner, and a pencil. So a red, blue, pencil, and paper. And I can help my hand in there.
You can be wherever you want. Okay, so here's a pencil.
If you want to give me some of those, I can hand them out.
Okay.
Did you guys?
I know, she's looking all official up here. That girl at the head of the class. usually this fight in class?
No. And everyone's following the instructions. Usually with kids, I have like curved lines that go like this, like going back and forth across the screen.
In my class, no one would be reading. Everyone would be like, can you say that again? Can you say that again?
Yes. So you are first going to draw a line. So you want to draw a line to collect all the gold but avoid the obstacles. And you can, so you're going to draw a line in the middle of the boxes. And so if you want to turn left to get there, you would draw a line. Yep. And since you turn, and then draw a line to the gold. And since you turned left here, what color would that be? Yep, so you would color that box blue because when you get to that box, you want to see if somebody can see that they're supposed to turn blue. All right? So now you're going to go to the next gold from there. And then you're going to have to, I mean, this helps me, or this is how I show my kids. I say, like, if you're going up this way, you should turn your paper like this and see, did you have to turn right or left? Because a lot of them say the wrong area since they're looking at it from a different view. Oh, do you want the colored pencils? Yeah, here. Yeah. So when I do this, is it so now you're turning your heading. So you wanted somebody to turn left. So now you're going this way. Yeah. So you would so you turn You want a new paper?
Okay, I'm ready. Is it time?
Oh, yeah.
Switch? Okay.
So once you're done, you can switch so that somebody else can see if they take the same route as you. So you should erase your pencil line, but leave the colored boxes. And the point of this is to see if somebody else will take the same path that you did based on your instructions.
I'm sorry, did you say go ahead and draw our pencil?
Yep.
On the partner one?
Yes.
Okay. So I can't read it sitting down apparently.
See, with this one, you're going this way, right? Yeah. So in this one, oh, yep, you're right. No, you're good. Yep, and so, yep.
Well, what happens if you run into a thing? Like you just get bit right there?
Mm-hmm.
Okay. Okay, so this one. I don't know. If you say it is. That's good. I hope I did it right too. I got it too, like, but it's here.
That's why we do this, is so that the kids can play for like minutes.
Yeah. So I just got bit. It just got bit, but it's fine. I'm okay. You don't have to worry. It's a tiny one. Tiny little one. I didn't even notice that little guy there. Tiny little.
Yeah, I was.
Yes, but it's okay if you did.
So do you guys have computer science going on in your school? No.
Did you get bit by any snakes or dragons?
Is it your first year?
Sidestep?
Yes. How's it going? So much. Last year was, it's been a couple years since I was in school, and then last year was my favorite.
All right, I'm gonna give you about 2 more minutes and then I'm gonna show you how this relates to the actual computer program. So about 2 more minutes.
It's like, whose right is it? Is this my right or your right?
But that's why we do it, because like the kids have such a hard time seeing heading. And like if I'm turning in this direction, it would be right. But then like if I'm facing in this direction, like it might not be the same direction as before if I turn right.
Have you been in CPS for a long time? So you know.
All right, I'm gonna go ahead and have your eyes up here so that I can show you the next part. So if you could just put those papers off to the side for a second. All right, so as I was going around and looking at a lot of your lines, I saw a lot of people who, when they were going through their friend's maze, saw, oh no, I accidentally put the wrong side when I was meaning to go this way, or I accidentally was supposed to turn right when I was supposed to go left, or I was supposed to go backwards. And that's great. That's the whole point of doing your partner's map, is so that you can see, oh, my heading should have been a different direction, because a computer is always going to see that. And so what this looks like when we do the computer simulation is this. So can I have it back on my laptop, please? All right, so this is what Star Logo Nova looks like. When you first pull it up and you have your own account, which I'm going to have you guys create in just a minute, you are going to see a blank green screen. And we call this Spaceland. And you can zoom in to make it bigger if you can't see. So you will see when this is already one that is pre-programmed for you, which you will have access to. You can start by painting landmarks. So I clicked the painting landmarks block right here. Now I have blue and red and black dots just like you guys had on your map. So these will automatically paint them for you. If you want to spread them out a little bit, you can try clicking paint landmarks a couple times, and so you can get the design you want. But it is always going to put red, blue, and black blocks. When you click setup, now I have 4 what we call turtles in the middle. You don't see 4 yet because they're all right on top of each other, but they're going to spread out in just a minute. So I just created 4 turtles, which are kind of like the people who act out our story. So now they're going to go through our Spaceland, and they are going to follow the same instructions that you had when you were making your maps. So if they hit a red block, they're going to turn right. If they hit a black block, they are going to turn left. A blue block, they're going to turn left. And if they hit a black block, they're going to make a 180. So after I click setup to put my turtles in the world, or like I say when I'm explaining it to my students, this is my classroom, I put all the chairs out, and now I put 4 students in the middle. So then I can say forever, because I want this program to run forever until I tell it to stop. Now I have 4 turtles moving. So you can see that the one that was right here just hit a black block and did a 180. It turned around. You can make this go a little bit faster if you scroll down on your screens. Oops, it's not showing up right here. I can pull it up a little bit, but later I might have to resize my screen. But this is the code for everything that you are doing. So again, if you just want to zoom in, you can drag this too over here. So zoom in, you can make it bigger if you want to see. But here's the code for that. So this is the turtle tab. This is saying, this is what I want my turtles to do when I click forever. So this is what I want my students to do when they get in the classroom. While forever's toggled, so while I have the forever button pushed, I want them to move forward by 1. And they're going to keep doing that over and over again while the forever button is toggled. But now they have some conditionals. If the terrain color is red, I'm going to turn right by 90 degrees. If my terrain color is blue, I'm going to turn left by 90 degrees. And if my terrain color is black, I'm going to turn left by 180 degrees. But we had to set up my classroom before the students could come in. We have to set up Spaceland before the turtles can be there. So I go to the World tab, and I have all of these blocks just to put those different squares in. So I can see right here that when I click the Paint Landmarks button, it's going to clear my screen, so it's not just going to keep layering all the different blocks on top of each other. It's going to delete all of my turtles. I'm going to create 1 turtle that has a size of 3, and it's red. And I'm going to create 30 stamps. you are going to have it has the 30 red stamps. I have my 30 black stamps, and I have my 30 blue stamps that are right here. I also have that when setup is pushed, I'm going to delete everyone, and I'm going to create 4 turtles that set your size to blue. So I'm going to show you something because I'm going to have you play with this for just a minute, in just a minute. But you can change these numbers. So maybe instead of 4 turtles when you click setup, you can say, I want 10 turtles. I would just have to click, I'm going to click setup to pause this. Only 4 turtles ran because here's what I need to do. If I change my code, I have to click run code. So anytime you make a change, you click run code. Now when I click setup, I have 10 turtles. And you can see how they react. You can also go through and you can change your size if you really want to, because this is what my students love doing on the first day. If you go to traits, and I can see that all of these are light blue. If you're having trouble finding it, you can look by color. You can say set my shape, so built-in shape, to a built-in shape. And maybe you don't want them to be turtles. Maybe you want them to be dragons. Maybe you want them to be sea otters. My kids love having dragons that are huge, that explode when they hit any of the blocks. And so I'm going to have you actually go into this program and play with it for a little bit. But let me give you some instructions first. Star Logo Nova only works on Chromebooks or laptops. It does not work on iPads or iPhones. And so unfortunately, if you're going to do this, you do need either a Chromebook or a computer. So if you could sit next to somebody who does have that, if you don't have one, that would be a huge help. What you will have to do first is you would have to go, and I have all the instructions, don't worry, I'm just showing you how to do this first. I'll put all of the instructions up. You're going to have to go to starlogonova.org, so slnova.org, and you are going to have to create an account. So you will have to create an account first. It takes 2 seconds. All you have to do is create a username or password. Then you have this. Then what you will do is you will follow the link that I'm going to put on the board in just a second, and you are going to follow the link to this page. To get it to be something you can edit, you have to do this. You have to click remix. It's like clicking save as on a computer. So right now it's view only for you. You have to click remix so that it's saved and you can edit it. Make sense? So I am going to have you play with this program for a little bit. You can go through, you can edit the code however you want. You can try changing the shapes. You can try changing the turtles. Maybe you want the blocks to be different colors. So I'm going to give you a few minutes to explore. And can I please have the presentation put back on because it has all the instructions on there? So here are the instructions. So you're going to modify the base model. You're going to go to slnova.org. Then after you create your free account, go to bit.ly/bumperturtle. Click Remix in the top left. Click Paint Landmarks, Setup and Forever, and see if you can modify the code to make the turtles do different things. So I'm going to give you about 20 minutes to do this. They do not need your pencils, and if, sure, yep. So I'm giving you 20 minutes. So you go to slnova.org, and you create the free account. Yep, and then so you're going to go through and create your free account, so you go to register, or you can click right here too. So you just make this, it's free.
Gold star. You get a tweet. Oh, Derek. 5 minutes early to recess. Yes. 'Bit.ly/bumperturtle, and it'll take you to the base model.
So you can open a new tab. Oh, so open a new tab. And then you're gonna type it up there in the address.
Oh, this, for this specific module, yeah, it's, she's already created the, classroom and then sends the kids a quiz in language. This is the assignment.
Oh, when was it today? I thought I had it.
And I'm sure that before they get to this point.
11:25? No, that might be totally fine. I was looking at the screen that was up here. So, and then, did you do any capitals in there? BUMP. What is it? For the slnova.org. Yep. And then to get to the starter model, after you register for the account, you go to that bit.ly, bit.ly/bunker journal. Yep. I wasn't going to, I can. Okay. And sometimes it just takes me seconds. And it works best in Chrome. I don't know which browser did you have it open in?
Safari.
Okay, it should work sometimes though. If it doesn't load right away, try Chrome and it should work. Edit. Oh, thank you. If it's not loading, you can try doing it in Chrome. Sometimes other browsers don't work the best with it. Is it here? Just a second. Let me look at something. They just sent out an email this week, or actually yesterday, saying with the new Chrome update, some computers automatically switched over to not loading Java. So let me go pull it up where I have the instructions.
Oh, very good. I mean, oh, you were already in there. Yeah. Okay, so then you're just. So once you logged in, what did you do? Once you, so now you go to the. Oh, the, I got you. Thank you.
still.
She's using my computer
Oh, okay.
right now.
Sorry about that.
No, that's fine.
I'm trying to find the email where it showed us how to do that fix.
Yeah, no worries. Unless there's someone else who's sort of in the back.
All right, 5 more minutes. 5 more minutes, and then we are going to move on. So 5 more minutes.
When you make changes, does it change immediately?
It should. Did you click run code?
Like I changed it to 45 because it was 90.
Okay, so yes, you just have to click run code.
Oh, you just click run code, then it'll.
Run code and then set up and forever. And then forever. So now it should change it. They like, my kids like making it where like if it hits a block, it blows up to like size 100. So then you have just enough for like 2 turtles on the screen because they're like whoosh, whoosh. Like you can't see anything else.
So if it hits a red one, it would go right. Hits a blue one, it would go left, and this one just makes it turn around. Okay.
So that's where you can like change the color if you don't want the boxes to be red, blue, and black.
Okay.
All right, I'm going to go ahead and move on just to show you what some of the other modules are that are included with the Project Guts curriculum. So what you just saw is bumper turtles, and it is part of Module 1. So this would actually be one of the introduction lessons to Star Logo Nova. So normally when teachers first start teaching this, I do suggest that they do a couple of other courses through like code.org first, just so that students kind of get a baseline of how to do coding. Because as you can see from this program, it's a lot to throw at them right away. And so I have found when students use the code.org curriculum, even if they're going through like lessons 3 or lessons 4, they have a much more solid foundation, and it makes it a lot easier to go through these lessons. So that was part of Module 1. some other things that are included in Module 1s, and I'm just going to give you a really brief overview of what is included so that you know if this is something that your teachers would use based on their curriculum. Module 1 includes a pretest where the teacher can kind of get a feel of how much the students already know for coding. They have an introduction to complex adaptive systems, so why we use computer coding for modeling. Then they have an introduction to Star Logo Nova. They have the Trailblazers activity, which you just went through. You have probability, so you learn how randomness works within computer simulations. They do a modeling of a spread of disease, and then they add instrumentation to their model and run experiments. So students can add ambulances, they can add hospitals, they can add the transmission rate. So after they've seen how an epidemic model works, they can change it to fit real-world scenarios. Module 2 focuses on earth science. There are two different modules there's two different lessons teachers can choose from with Module 2. The reason for that is because in a lot of states, they have not accepted or adopted the next generation science standards, and that's because the next generation science standards do include information about climate change. And so because of that, they offer a climate change model and a model that is standard on everything. But there is the lessons for both of those included on the Project Guts site. The one that everyone sees is designed to be used in an earth science classroom. So at our school, it's 6th grade. It may be different at your school. It focuses on the water cycle, water being a shared resource, and what happens when it becomes overused. So they watch videos with Jay-Z in it, where he goes to different developing countries and they learn why clean water is so important and why we shouldn't completely deplete our water sources by overpumping and wasting water. So they make different water pumps. They see what happens to the water cycle when more pumps are added. They see what happens when acid rain is introduced and how that can play with the water cycle. So they have introduction of the, again, that's all just earth science. So if you are having an earth science classroom that wanted to use the Project Guts curriculum, they should start with Module 1 and then go to Module 2. They don't have to teach all of the other modules. So they can just do those two that are applicable to their classroom. Module 3 is life science. So for the life science classroom, they would only have to do Module 1 and Module 3. They would not have to do 2 and 4. Module 3 is designed to be life science. It focuses on food webs, and students will measure the amount of energy being used by rabbits as they eat grass and how changing one variable in an ecosystem can affect others. So they go through and they add prey then that eats the rabbits. And they say, how does that affect the grass that's in that ecosystem? Because they do have the rabbits die off if they don't eat enough grass. Or they say, what happens if there's a drought and all of your producers die? How does that affect your rabbits? How does that affect your coyotes? How does that change your ecosystem? So there are 5 lessons in that. Each one of these lessons would not take one day. I would say for these lessons, each one of them would take about 3 days to fully get through them. Module 4 has to do with physical science. And it focuses on chemical reactions at the microscopic level. Students combine copper with silver nitrate, and they watch the breakdown as if it was under a microscope. They also have extension lessons where students can mix salt and water and see how those ions form. So it's a little bit simpler of a concept, but still using the same module. So they get introduced to chemical reactions, they see what happens on the microscope level, and they actually see why different precipitates are formed. So do you need to do all these modules? Like I said, no. And if you want to have it where maybe a person that's doing technology teaches Module 1, then your science teachers would only need to teach the science content lessons in their classroom. And so you do not have to teach all of these in order. You would only teach Module 1 to introduce the program, and then that science discipline. If you still need help, the site does offer a MOOC. The sites can be found here on, and I can put up the page in just a minute, but it's the projectguts.org page. So Project GUTS, and GUTS stands for Growing Up Thinking Scientifically. So that's what the GUTS is, Growing Up Thinking Scientifically. Resources also include information about modules in a forum for questions, rubrics, and lessons ideas. The person who is in charge of GUTS is Irene Lee, and her email address is listed here. And she can give you any help you need as you go through and implement the curriculum. I'm going to show you really quick what that Project GUTS website looks like. If you can pull back up my computer, please. So when you first go to the projectguts.org page, it looks like this. If you go over to Classroom Resources, you can see that it has a lot of different links for teachers to follow, where it gives them all the information they would need to start this. So if you go to GUTS, code.org, CS and Science Curriculum, it has all of the different modules listed here. So those are PDFs giving the standards, the instructions for the teachers, ways to assess the students, solutions to problems students might have. All of those are listed here. You also have links that will help you with each one of the modules, which include PowerPoints that are already created for you, and different sheets that you may need. So for example, this is a sheet where it's just listed right here, where if you want to print out the sheet for your students, you can. You have videos that are linked to this. You can also go through, if you go to Classroom Resources and they click on Teacher Resources, they have different pages that might be really useful as they go through and implement this. So I know that's one that I use all the time in my classroom. Under the Resources tab, if you click on All Blocks and Drawers, it shows students what the blocks are in all the drawers. So again, this is something where it's a little bit more difficult than the code.org program to use, but it's really cool how it ties directly into the science curriculum and enhances students' learning so that they can see how what they're learning in the classroom applies to real life. So that's it.
Does anybody have any questions? Yes.
Yes.
Yeah, like on the spreading of disease module,
Mm-hmm.
did you have like, okay, this is our school, we have 1,400 students, so like on the spreading, check, on the spreading a disease module, so can you like set up the variables where you have like 1,500 students, you have a community, and this is the density of this community, and if you get pink eye, how, given, these variables, that's how,
Yeah.
there's a scenario where this is how the spread of the disease can happen over time.
Yeah, they can even create data boxes, so it shows them using line graphs what the population is that's affected over time. And you can change the transmission rate. So where pink eye, which is highly transmittable, is a lot more easily spread than, say, like if you had, I'm trying to think, we did Ebola because my kids love Ebola. So we talked about how Ebola can spread through it, where that's actually like a relatively low amount of people who can get Ebola. And so we talked about transmission rates that way, so.
Anybody else?
Yes.
So does each science teacher need a Chromebook card?
They would, but I have an iPad cart in my class. So what I would do when I was teaching it, so I would just say on Fridays, can we just switch carts with another classroom? So like you can use my iPad cart that day and I'll use the Chromebook. So we just had it where like for a month, I would use their Chromebook carts on Fridays. And so we didn't have to buy any new technology.
Hi.
Okay, one up here.
When you started doing this, did you have any computer science background? Were you a science teacher?
Good
And how easy or how hard was it for you?
So I had zero computer science background, and I went through this 3 years ago as somebody who just wanted to implement more computer science in my classroom. I would say because I am more technologically adept, I was able to go through it, but it was because I was okay like getting really frustrated with something and working at it. I know that a lot of times when I'm finding, the hardest thing is when I'm teaching this in my classroom is that if you get frustrated with something, I want you to keep working on it, which is something we should be teaching our kids anyway. And so that's been the hardest thing that I've seen work through, where they're just like, well, I don't get it, I can't figure it out. And then they just sit there. So we kind of have to go through and work through it together. But also there's some kids who totally get it, and they're doing things that I don't know how to do. And so they'll ask me how to do something. I'm like, let's figure this out together. So like, here are the steps that I know how to figure this out, but I don't know this other part. So what can we take from what we both know to figure it out? So there's a lot of times that I'm going through and learning about it the same time they are, because I don't have a background in this. So it's kind of just getting used to it.
So if I could add something to that, I would say our most successful teachers do exactly what she said. And as a principal, I would really encourage you to encourage that same productive struggle in your teachers that we are encouraging in our students. Students are really encouraged to see teachers who want to learn and say, and are not afraid to say, I don't know, or let's learn it together. Then that sort of decreases the distance between them and their teachers, and really beginning to believe in themselves that they can learn anything. If my teacher is willing to, with all of his or her degrees, step out and learn something new, I certainly can as well. So that's a really important concept to really take home with you.
Yeah.
Any other questions? I think this has got one. No? Okay. Okay. Oh, yes.
Good morning. I have a comment. We actually did a blended learning exercise using the Star Logo Nova with our interactive science, where they were offline reading, getting that background information in the different modules, and then going in there to do their labs through that. And that was very successful with the 6th through 8th graders.
Oh, good.
So it
I'm
does
glad.
work.
Yeah.
Hi, I have 2 questions.
Yes.
So how often should the kids be doing this? And how is literacy connected? Do they read on the computer about what they're learning?
Yeah, and so obviously every classroom is going to be different on how often they implement it. Like I say, I try and do it once a week, just so that you're not leaving big gaps and they forget what it is, because there's a lot of information in here that you should kind of keep up, just so that students remember where things are, or they remember how things work. So it's not constantly going back and saying, well, it's not working. Oh, it's because I didn't click run code. So kind of just getting them refreshed in that. So I would suggest once a week if you can. Maybe if you can do it like every other week, if that's what works in your classroom. I just know that it really spreads it out doing it that way. And how it ties in with literacy, they're reading everything. And like I said, with the epidemic model that we just did, they had to go through and research the transmission rates. They had to read about how that disease spreads to the community. They had to learn about like what the amount of people were that were immune to the different diseases. So all the research that they put in before they even used the computer model to show how it works in real life was all reading based.
Learning that, okay, I've got this project. The first thing that I can do is go out and find out on my own, inquiry-based. So we're really trying to, with computer science, we're really trying to, of course, teach computer science, but we're trying to teach all those really important other skills that any kid, no matter what he or she does, needs, first to be successful in K through 8, then 9 through 12, but then in life.
Yeah.
Any other questions?
Oh, cool.
And then you can use Flash-based things. So we use it in the classroom from time to time to get around the fact that you can't run things like this on an iPad.
Okay.
PHOTON, Photon, is an
Photon?
app that
Okay.
bypasses that.
Awesome.
Okay, thank you for that.
Awesome.
There was another one where there was like an ed site where it kind of used Flash before and it never worked for us, so I'm glad to hear that.
Can you use this on a desktop or?
Yep. And it's all web-based, so they don't have to have a desktop to do any. I mean, like, you can use it, but it's all web-based. So it's not like Alice where you have to have it download onto the desktop.
Anything else? Okay, so once again, we're going to want your feedback on this experience and what we could do to make it better so that you could be more prepared to know how to choose this or choose something else, okay? So with that, if you don't have any other questions, let's thank Carrie.
Thank you.
Okay, and then we're going to wrap up. We're going to have our colleagues come back and join us, and we need 5 minutes more of your time, and then we'll set you free. If you want to just take a second while they're coming and go grab some more snacks, feel free to. Okay. I promise to take 5, maybe 6 minutes just to kind of wrap some things up. So just want to let you know, you will be getting a link to a Google folder that has all of the materials from today and more, including the curriculum guide that we just released in draft. That's K-12. It's got the standards in there. It's got sample curriculum. You've been given a taste of just a few of the curricula that we offer at each grade level. All of the ones that we have as of now will be there. Also know that that guide is going to be under constant revision, so that by the time teachers come back, they're going to have an even more interactive guide. This right now, it's just the information, but we'll make sure that there's layers of support available so that they can find out what they need. We're also designing a guide that will help them to, in preparation of whatever lesson that they're learning, the concepts that are there, give them places that they can go out and do some self-learning. You're going to be teaching about algorithms. Here's a video. Here's a course. Here's stuff, so that they have that sort of reinforcement. We're also going to be asking you to encourage your teachers to sign up for the various PD that are available starting in June. As I mentioned, the Apple curriculum that is just released, that some of you got to experience, that and some partnerships that they have with CodeSpark and with Tinker. There will be PD for that in June, and we'll be offering subs to your teachers if they're able to come out. So a couple other things. One of the key things that we're going to really be pushing out this year is the concept of going deep. One of the blessings of having teachers like those in your schools be willing to get started, and you've met some of them today who didn't know anything about computer science and they're now doing marvelous things, is that we were able to do this, right? We would not have been able to do computer science for all if we had not been able to take willing people who didn't have that background, who were willing to jump in there and learn. However, one of the challenges that we're finding is that many times people who get started they've got that narrow band of knowledge, and so what we're finding is many times they skip across the tops and they move on to things that when there's a lot of richness still left in those grade bands. And so we're going to be helping and encouraging that sort of spiral learning so that students can go deeper into the concepts at their grade level. One misconception that I'm hearing often is that, well, we've already taught them about loops. They're done with that. Shouldn't they go on and learn C++? Absolutely not. Okay, you learn to add in first grade. Did you give up on adding in second grade? Were you done adding when you got to third grade? It's the same concept with these concepts that we are teaching students. I'm a software engineer by trade. Some of the concepts that we're teaching is the stuff that we used in industry. So you're not going to be done just because you've done it. And a first grader learns differently from a third grader. I have to tell you, right? You're telling me this stuff? Okay, so I'm not going to even go there. Okay. So just a little bit more on why we're doing. I always like to spend time explaining why we're doing what we're doing. We're teaching computer science because it's a wonderful thing. You already heard Britton talk about a lot of the opportunities. But with computer science, we're really focused on computational thinking, making kids thinkers. We're focused on problem solving and creativity and innovation. We're focused on teaching them that there's more than one answer. This is the class where there's more than one answer. There are multiple solutions. We're focused on growth mindset, teaching kids that they can do, that they have no limits. Their limit is where they decide it should be. And most of all, we want to teach them to be inquirers, to always want to learn. Equity is the cornerstone of what we're doing. When we named it Computer Science for All, we meant all. And so if there are ever any problems that you have, that you're thinking of and reaching any of your populations, please let us know. Know that we've reached out and we're working with, what's her name? UIC? No, not UIC. U of I at Urbana. To focus on our special ed populations and how we can really make sure that they get what they need in computation. And so we're now that we've kind of pushed wide, we're starting to figure out those focus areas so that we can make sure that no one is left out. Because most of all, we need problem solvers, especially in today's world. We need to make sure that every child's mind is open and available to help us to create our solutions. So, with that, I want to make sure that everyone's questions have been answered today. Are there any further questions? Wait for the mic. We're being taped so that people who couldn't come will be able to watch and learn from what we're doing. So if we can run over with the mic, and everybody will get to enjoy it later.
Yeah, my question is how does the school get the Star Logo Nova account for the students?
Yeah.
How does that work?
Yep, so Amy can tell you more, but first thing is you need to get those teachers into that PD, and they will learn how to do all of that account setup and all that stuff. But it's out there. If you saw the website that she took you guys to? No, it's free. It's all free. Yeah, any other questions? Okay. While y'all are thinking, because I know you got questions, okay, I want to take this opportunity to introduce our wonderful staff that we have here. Can the CS staff please stand up? And because the light is in my face, I can't see, so I'm going to have y'all shout out your name and tell folks what you do.
Curriculum Instruction. Carmen Edwards, Strategic Operations Manager.
Andy Rasmussen, Special Projects.
Troy Williams, Integration Manager. Scott Summers, Integration Specialist. Arun Arshi, CTE for Executive Education Program Coordinator for Technology.
Michelle Mon, Integration Specialist.
I'm Missy Tobian. I'm also an integration specialist.
Okay, thank you. I'm so blessed to have this great group of people to join, and they're here for you. Their purpose is to support you. Many of you may have met them, met one or two of them already. We're coming out to your schools to help you do what needs to be done. Finally, I want to say thank you for preparing our students to get into high school and be successful with that graduation requirement. You know, we're thankful we got that job done, but now we got to do it, right? So now we got to make it happen. And because your children are going to be coming into high school with that heart for learning and knowing what computation is and what they can do with it, so many more exciting things will be happening for them, not only in high school, but in college and beyond. So again, thank you for all of your support and all of your hard work, and please don't ever hesitate to reach out to us. So now one more shot. Here's your final chance for any questions or parting shots. Okay, well, I'd have to say goodbye for now and have a great day. Thank you. Okay.